Welcome again. So in the previous video, we learned how to solve the convolution sum if your sequences they are explicitly defined and they have finite number of elements. But there may be cases jahan pe it may not be that way, that your sequences they may not be explicitly defined. So us case mein again you have to use those three steps. You have to forward one of the sequences, then shift it by an appropriate amount, then multiply and then perform the summation. Right? So we'll take an example, take a simple example. I have an input sequence x of n, which is a unit step sequence. The unit step sequence is an infinite sequence because it is defined for n greater than or equal to 0. So they're not finite number of elements. Right? Although value 1 throughout, but as far as samples are concerned, they are infinite in number. Then I have been given the impulse response as an exponential sequence multiplied by unit step signal. So it simply means, since it's multiplied by u of n, it's only defined for positive values of n, that is n equivalent to greater than or equal to 0, because your u of n is defined for n greater than or equal to 0. And chunki value 1 hai, so it simply multiplies alpha raised power n with 1 for positive and 0 values of n. Okay. And also it is given because it is an exponential signal. If you remember, जब हमने discrete exponential पढ़ा था, so it actually depended upon this base. So it is given that this base lies between 0 and 1. Fine. Just have a look at your notes या जो अगर आपका lecture होगा पास में ही. So I think we had this defined the exponential as something like this, b r alpha, something like this, right? B was the amplitude, so यहाँ पे amplitude is 1, so we have neglected this. Then depending upon the value of r, you either had a growing exponential or you had the decaying exponential. And if r had a greater than 1 value, it was a growing exponential, and if it had a value between 0 and 1, it was a decaying exponential. You can check this out, just visit your previous lectures or previous notes. Anyways, the limit here given is between 0 and 1, so it obviously means it is a decaying exponential. Right? Now we can't use the conventional this methods. We can't use the multiplication method. We can't use the tabulation method, because this is not a finite sequence. This is an infinite sequence. Okay, दोनों terms में we have unit step, which means it extends from n is equal to 0 to n is equal to plus infinity. Right? So we'll have to rely on those char steps, shifting, folding, and all that. Okay, but before that, again, as has been our practice, we'll try to plot the signals first. X of n is ये तो बहरहाल simple सा ही है. It is a signal of this kind, starting from n is equal to 0, n is equal to 1. It will have samples having a unity value. Okay. So again, I'll be using a dummy variable x of k. It is actually u of k. 0, 1, 2, 3, 4, dot, 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 up to infinity. So this will be k. Fine. Then we have h of n. First important thing is it is multiplied by u of n. So again, it will be defined only for the positive values of n. So it will be an exponential. I will try to just to make it an exponential. something like this, huh? So this will be my h of k, which is alpha k. I'm just replacing n by k. I told you that is that mathematical thing. We tend to replace original variables by the dummy variables. Fine. So these will be values 0, 1, 2, 3, 4, 5, 6, 7, like this. Okay. Now for the computation of my convolution sum in this case, so my y of n, it will be x of n convolved with h of n, and it will be actually this summation k running from minus infinity to plus infinity, x of k h of n minus k. Fine. Now x of k is, it appears like it is in the summation. This is something we need to derive graphically, right? So this basically is done. First of all, I will get h of minus k, fine. Then I will get h of minus k minus n, which will be basically h of n minus k. So I have to perform two basic operations, folding, then shifting by n. Okay. Folding is pretty straightforward, you just change the axes. So let's do the folding first. तो फोल्डिंग में आपके वैल्यूज स्वैप हो जाएंगे. So 0th value it will stay as it is. 1 will come to minus 1, so I mean whatever the value is like this. 2 will come to minus 2, 3 to minus 3, like this. Fine. So this is 0, minus 1, minus 2, minus 3, minus 4, minus 5, and dot dot dot. So there will be no positive value after folding. So this is actually my h of minus k. Fine. So it will be actually alpha minus k. You are replacing k by minus k. So this is the actual mathematical representation. This is how we do it graphically. Fine. Then I have to perform shifting by n units. Fine. Now it depends आपका n का value क्या है. If it is positive, that is if it is greater than 0, then it will be right shifted, which means ये आपका जो entire waveform है, this will be shifted right. And if it is negative, if n has a value less than 0, it will be shifted by left by that much unit, that much amount of time. So I'll take a new page out here. Yeah, I'll do one thing. Anyways, let's just plot it separately. So I will have two plots, one for the negative value of n, that's n less than 0, and the other one for the positive values of n. Right. Now for n less than 0, that is here, we have h of minus k. Now we need h of minus k minus n, and if n has a negative value, which means it will be k plus n. Plus means you have to shift towards left, which means ये जो आपका ये waveform है, it will be further shifted towards left side towards the negative axis by n units. Okay. So it will appear something like this. Suppose somewhere higher I have, say this is n, so आपके जो samples है, they will be shifted accordingly. So first sample will appear here, then जो भी values है, they will follow. Please remember, shifting keeps your waveform intact. आपके samples में कोई change नहीं आ जाता, just that the waveform is shifted towards one right or left, right? So this here will be my h of minus k minus n, which is actually equivalent to h of n minus k. You are replacing k by n minus k, which will be mathematically alpha raised power n minus k. This is the graphical thing for n less than 0. Right? तो इसमें जो आपके samples है, they are extending from minus infinity to n. ठीक है? Now the other case, if n is greater than 0, तो उस case में आपके जो samples है, they will be shifted right. So waveform will be something like this. Like this, right? So again, this is h of minus k minus n, which is h of n minus k, which is alpha n minus k, but n here is greater than equivalent to 0. Okay? And this point will be n. It continues to minus infinity. So let me just write it down here, that for n less than 0, that is this, sorry, for n less than 0, if you compare x of k and h of n minus k, now x of k is this, it's only defined for positive values of my time axis, that is k. But यहाँ पे you don't have any values for the positive time axis. So for n less than 0, x of k and h of n minus k, they do not overlap. Fine. Which means if you take the product, it will product, then sum it up. क्योंकि हर कोई product term, it will be 0. So summation will also be 0. Right? Now coming to this side, for n greater than or equivalent to 0, there is an overlap. And overlap between x of k and this is understood, between x of k and h of n minus k. And this overlap extends from this point, because your x of k is defined from 0. And it extends from k is equivalent to 0 to k is equivalent to n. यहाँ से लेके यहाँ तक. ठीक है? So जो आपका output होगा, it will be y of n is equivalent to summation k running from 0 to n. The mathematical form of the signal is alpha n minus k. Fine, but from 0 to n. I can convert it into a more standard form. So I'll do a simple substitution. Let me put m is equivalent to n minus k. Then as k is equivalent to 0, आपका जो m होगा, it will be n. And as k is equivalent to n, m will be equivalent to 0. Okay? So I can make this substitution, y of n summation k0 के बदले, because I will be expressing it in terms of m. तो जब k0 है, m का value n है, so it will be m running from n to 0 and alpha raised power m. अब चूंकि summation है, आप n से लेके 0 तक summation कीजिए या 0 से n तक, it doesn't matter. So I can very well express it as m is equivalent to 0 to n alpha m. This is a standard sum. This is the sum of the first m powers of alpha. Right? So it's a GP, geometric progression, and it has a standard value of 1 minus alpha n plus 1 divided by 1 minus alpha. Okay? This is a standard sum. So you can express कि जो आपका y of n है, it has a value of 1 minus alpha n plus 1 divide by 1 minus alpha for n greater than equivalent to 0, and outside this range it is 0. Okay. And sometimes there is an alternate way of expressing this thing कि अगर आपका signal it only extends for the positive values of n, you can simply do one thing: take this value and multiply it by u of n. This is an alternate way of expressing this thing in terms of unit step, because we know unit step, conventional unit step, it extends from 0 to infinity. So अगर आपका signal is also defined for that particular range, you can simply multiply it by u of n. Right? So this is a typical example कि जहाँ पे जो आपके participating sequences है, whether it's x of n, whether it's the impulse response h of n, and they're infinite, they're not finite. So you can't use a conventional tabulation and multiplication method. So you have to rely on these shifting, first folding, then shifting, then deciding on, like in this case, we have to decide on n, whether n is equal to 0 or n greater than or equal to 0 will overlap with your original signal x of k. Right? So accordingly, you will get the response of the system. Right? So stop here. Next time, next video, we'll see the properties of the convolution, like we did the convolution integral. You see there we will have the properties for the convolution sum.